Hi, and welcome to Graphical Data Analysis using Python MatPlotLib. So my name is Scott Bartow, and this class is offered to you by the Clifton Park Half Moon Library. Tonight we're going to be talking about the Python library MatPlotLib. And what this does is basically gives us a way to present data visually using different kinds of charts and graphs. So if you look at my screen on the right hand side, I've got the Python shell loaded up. On the left hand side, I've got my command line for my Windows machine. And so what MatPlotLib is a graph plotting library in Python that serves as a visualization utility. So it is open source, so it's free for everybody to use. And most of MatPlotLib, the library, is written in Python, but there are a couple of little segments that are written in C, Objective-C, and JavaScript. But really, you're going to be using almost entirely Python in when you use MatPlotLib. So the way to get started is you want to go out to python.org, and you want to download Python if you haven't done it already. And when you download Python, you will you'll have the latest version of Python loaded on your machine, and included in that is something called PIP, which is sort of like an installer for the Python libraries. So once you have Python installed, you'll be able to go into the Python shell, which you see on the right-hand side of my screen, and the way to install MatPlotLib is to go out to a command line. So you can see here with the black background, you can see the command line. I've got my hard drive C:// users /sbart is the name I'm going to be using. And all you have to do is, I've already done it, so I'm not going to run this, but you just have to put the command pip install, pip space install space, and then matplotlib. And if I hit enter, it would install MatPlotLib on my machine. Another thing we're going to be using tonight with MatPlotLib is NumPy. So the way to install that would be pip space install NumPy. All right. And that's how you would install these two libraries, these Python libraries, onto your machine. All right, so I'm going to close out our command prompt. Right here. And let's see, I've got my Python, or my Python shell. And you can see here it says Python shell in the upper left-hand corner. And if I do file, new file, now it opens up a screen, and this is the IDLE text editor for Python that also comes included with your Python download. All right, so now I have my text editor on the left-hand side of the screen, and I have my Python shell on the right-hand side of the screen. And once you've done the download for MatPlotLib and for NumPy, the way to test it out is to go to the Python shell. So look on the right-hand side of my screen at the command prompt. So for the Python shell, the command prompt is 3 greater than signs. And here you want to type import matplotlib and hit enter. And boom, my prompt comes up, which means that, hey, I have MatPlotLib loaded on my machine. If an error comes up, then you have some problems, and you have to check the install and see what your trouble was. The same thing you want to do import space numpy to see if that was loaded correctly. I hit enter, and the prompt in the Python shell comes back with 3 greater than sign. So that tells me that both libraries have been loaded up on my machine. All right, so that is how you get your machine all set to use MatPlotLib. Okay, now why don't we let's start using it right away. Okay, so most of the MatPlotLib library utilities lie under the PyPlot submodule. All right. So what we're going to be doing is over on the left-hand side of my screen in the idle Python text editor, I'm going to import for my program, import matplotlib dot pyplot as, so we give it an alias name, so we don't have to type that out all the time, as PLT for pyplot. All right, hit enter a couple times. All right, so now the pyplot package can be referred to as just simply PLT instead of trying to refer pyplot by using matplotlib.pyplot. So its alias names are just abbreviations, and they're nicknames that we're giving this this package and submodule. All right, so hit enter. And now let's also import numpy. So import numpy as, and import numpy space as np for numpy. So we give it an alias name with just 2 letters, so it's easier to code. All right, hit enter. All right, so now we're going to have to do x coordinates. All right, so we'll create a variable called x points space equals. We'll give it a value. So we reference the NumPy library, np dot array. And then in parentheses, we're going to do 0, comma, space 6, and parentheses. All right, that's going to be, actually, inside the parentheses, these coordinates have to be surrounded by square brackets. All right, so it's the variable name x points equals np dot array, parentheses, square bracket 0, comma, space 6, and square bracket, and parentheses. All right, now we have to create a y coordinate variable. So y points equals np dot array, parentheses, square bracket, and we'll give this a bigger array. So 0, 250, n square bracket, and parentheses. Hit enter a couple times. And now we're going to reference the matplotlib pyplot library. All right, so we will do plt dot plot. So we call the method plot, and then inside we're gonna reference the values inside the variables x points, comma, y points, comma, y points, and then a parenthesis, and then hit enter, and then we'll do plt dot show, parenthesis. Right, and plt is referencing the matplotlib.pyplot submodule, and inside it has a method called show, which will allow us to show the visualization. All right, so what I'm going to do now is up in the toolbar, we're going to click on run, and then run module, the third one down, and click OK in the pop-up window. And it'll bring up the option first time through for us to actually name the file we want to save to. So we want to create a new folder for this class, MatPlotLib. So I'll do this, and inside of this, I'm going to do, I don't have it already. Nope. So here, and I'll create a new folder, and I'm going to call it, let's see, what's my title? Graphical data analysis using Python, MatPlotLib. Enter. And double click on that new folder. Now down here, the save as type is Python file, so you don't have to change that. And for the file name, I'll call it what will I call it? I'll call it how about chart1? Chart1 dot, and I'll give it the Python extension .py. I don't have to because the same as type is already pointing to a Python files, which means it will give it the extension .py automatically. But I just want to show you that all Python programs have to have an extension .py. So I called my file chart1.py, click save, and it will run. Unless there's an error, and over in the Python shell, you can see it's running away, running. Analysis using that. Taking a little while. Oh, here it is. All right. Okay. So off to the left now, the window came up with our chart. All right. So so the x coordinate was, let's see if I can shift this over. Okay. So the x coordinate that we created with the variable x points had a range of 0 to 6. All right. So you can see here's the s line, s axis. And we have 0, 6. Now, the y-axis, as defined by the variable y points, we have 0 to 250. And now, if you look at the y-axis, we have 0 to 250. So that's what these things were doing. So down here on this line, we call plt dot plot. So the method plot, and we feed it the values for the x-axis and the values for the y-axis. And then we call plt.show to actually show it like we see here. So, and down at the bottom, underneath our chart, we have a bunch of different options like save, zoom to a rectangle, and we can like pan the axes. We can go back to previous view, forward to the next view. All right, so that's our first MatPlotLib program that we just wrote. All right, let's see, what should we do next? Okay. All right, let's do a little bit of plotting. All right. So our first program we used the plot method right over here on the left-hand side. And the plot method function, the function is used to draw points or markers in a diagram. All right, by default, the plot function draws a line from point to point. The function in which we can see here, this is the default. The line is drawn straight diagonal from the 0, 0 point all the way up to the 256 point. All right, so the function takes parameters for specifying points in a diagram, which, so if you look at our function, our plot function, it takes 2 parameters, right? First one, the x points, and second one, the y points. All right. If we need to plot a line from 1, 3 to 8, 10, we have to pass two arrays, 1, 8 and 3, 10 to the plot function. All right, so why don't we give that a try? So what we're going to do is we're going to change our x points, and we're going to change, instead of 0, 6, we're going to change it to 1, 1, 8, and for the y points, we're going to do 3, 10. All right, and everything else is all set. So now I'm going to do run module. Click OK. It's already saved. Oh, invalid syntax. I don't have the opening square brackets in front of the one. Run module. Click OK. And I'll just have to wait a second. You can see over on the right, the Python shell, it's actually running the file. And that's the result. We kind of, oh, okay. Yeah, so all we did was we changed the y-axis points 3 to 10 and the x-axis points 1 to 8. All right, so now, what if we wanted to plot without a line? To plot only the markers, you can use the shortcut string notation parameter O, which means ring. So what that means is, all you have to do is you have to add another parameter, right? So I'll close this out. So say I just want the points. I don't want the line to go all the way through it. So if you come down to your plot function, you add another parameter after the y points, and this is going to be single quote O, lowercase o, single quote. All right, and so what that'll do is we should have a point down at 1, 3, right? 1 and 3, and a point up here at 8 and 10 without a line. All right, so to run module, click OK to save it and run it. And all right, so we're plotting, and we're only plotting the markers. So see down here, we have an x-axis of 1, y-axis of 3, and it plots that point. And then we have x-axis of 8, y-axis of 10, and we plot that point. But there's no line going from point to point. All right, so I'll close that out. Now, what if you have multiple points? So remember, our variable x points and y points, these are arrays, right? And we're calling the array function from the NumPy library, NP. All right, so but what if we had a whole bunch of values in here? 2 and 6, 8. All right, and then we have the same matching variables, values down here, same number of values, y values, as we had for the number of x values. So 3, 8, 1, and the last one would be 10. All right, so now we have 4 x values and 4 y values. All right, let's see what happens. Now I'm gonna take out the third parameter in our plot function. Okay, and I'm gonna do I'll do run module, because now we want a line to be drawn. We don't just want the markers, the point markers, to be on the chart. So I click OK. There we go. All right. So it takes the points, it comes up here, then it went down here, then up here, and it drew the line. All right. So this is how you plot stuff using MatPlotLib. All right. Now, if you don't specify the points in the x-axis, they will get the default values 0, 1, 2, 3. All right. So say we don't have the x-axis, right? So what we'll do is we'll comment this out. Now in Python, the comment is a hashtag. All right, so I'll take that out. And then in our plot function, I'm going to take out the parameter x points and only have y points. And then up here, I'm going to have 3, 8, 1, 10, and then I'm going to give it two more points or values, 5, 7. And so now what this will do is if you don't have any x points or any x-axis values, it'll default. So the first value will be 1, second value 2, then 3, then 4, then 5, then 6. Because we have 6 values for the y-axis, it would go from 1 all the way up to 6 for the x-axis. So it'll be 1, 3, 2, 8, 3, 1, 4, 10, 5, 5, and 6, 7. All right, so we're all set. I'm going to do run module, click OK, and then we are going to see a very nice chart. And that's it. So if you look at the first point, it's going to take 1. Let's see, where's the first point? So that's 1. And then that's 3. 3 on the y-axis, and 1 here, and then 2 here. Okay. Yep. So that's how you can default the x-axis values, and I believe the same would be true for the y-axis values. So if I had x values and didn't have y values, then it would take for the y values it would do 1, 2, 3, 4, 5, as many numbers as there are items in the x-axis. All right, so that's how you plot. Now, all right, so what if you wanted to do markers? So markers are just points, right? You use the keyword argument marker to emphasize each point with a specified marker. All right, so taking this example, right? What if I wanted to use markers, all right, so I still have, for my plot function, I still have y points, right? I don't have any x points. I commented those out, comma, and then you use the argument marker equals single quote, lowercase o, single quote. All right, so let's see what happens. We'll do run. I'm going to get rid of this chart, right? Do run module, click OK. And there it is. All right, and so what it's done is by using the argument marker, what this does is it allows you to have the markers stand out. So it puts a marker at each point, right? So that kind of makes it stand out a little bit better. Now, you don't have to do like a dot for the marker. What you can do is instead of the O, so that's why you're using the lowercase o, because it'll do a round dot that's filled in. And what you do, what if we wanted to use a semicolon? I mean an asterisk, right? So oops, but you probably use that character. Let me see. All right, so I've got a tilde, and I do run module, click OK, and what comes out? Here's our chart. And say now I've got like triangles. So you can change the look of the marker just by choosing a field. When you have marker equals, and whatever you put in the single quotes is what you're going to have. So what if I did, how about 3 S's and get rid of the tilde? I'll do run module. Let's see how this looks on our chart. Oh, error. It didn't like the style. I think it has to be a single character. Let me see. Oops. This back. I'll get rid of 2 of the X's and just have marker equals X. Run module. So that threw an error over on the right-hand side in my Python shell. Yeah, it only can be one a 1 character marker, not 3 like I had before. So these are X's that are filled in. All right. So let's see, reference. Oh, okay. Yeah, there's a bunch of different marker references, markers that you can choose from. So I'd say the O is a circle, the asterisk a star, the dot is a point, S is a capital S, an S is a square, a D, capital D is a diamond, a lowercase p is pentagon. So there's a whole bunch of things that you can use for different types of markers. All right. So now, if we want to format strings, we're going to use shortcut string notation parameter to specify the marker. This parameter is called an FMT, and it's written with the syntax marker /line /color. All right. So what if we do? What if we do this? All right, so we're going to have marker equals, and let's say in the single quote, we're going to do the lowercase o, and then we're going to do a colon, and then we'll do a lowercase r for red, right, for the color red. All right, so the format is going to be the marker, which is this character, and then dots for the line, right, by using the colon, 2 dots, and then the next argument is the color as symbolized by a single letter, right? So R is red, B is blue, etc. All right, so let's run this, and you'll see how the chart turns out. It's pretty nice. So, okay, it didn't like that style of. It didn't like. Get that. Oh, I don't need marker in there. Oops. Do need the single quote. So it's y points, comma, and then I don't need marker equals. All right. So as you see on the right-hand side of my screen, under the Python shell, I've got a whole bunch of errors. It didn't like the format of that marker. All right, let's see if this works, and it does. All right, so if you look over here, you got the first character is the marker, second character is the line, and the third character is the color. All right, so the marker is a circle, which we have all our markers, all our points are circles. The dots are what the line is, instead of being a solid line. And R is for the color red. All right, so if you see, instead of R, I chose O. Let's see if that turns it orange. So you can play around with the different different arguments for the, oh, it didn't like that. I'm not sure what the other colors are. Let's see. All right, so I've got different, oh, there it is, okay. All right, so I put orange. Yeah, there aren't a whole lot of colors. There's white, black, yellow, magenta, cyan, blue, green, and red. All right, so if I wanted this to be green, I would do G for green. And if I didn't want dotted line, I wouldn't have the colon. What I would do is, if you want a solid line, you do a dash. So there are a few ways to do the line. A dash is solid line, colon is a dotted line, like we just did. Dash dash is a dash line, and dash dot is dashed dot line. All right, so I'm just going to try this with a dash line, with a solid line, and with the color green for our chart. All right, and here it comes. There we go. So it turned to green, and now I have a solid line, but I still kept the marker of a circle. All right, so that's that. Now let's say marker size. All right, so say I want my marker size to be bigger. So if I do, I'll do a comma, ms equals 20. All right, 20 pixels. I do run module. See if this works. Yeah, all right. And it makes the markers themselves ms that we just added. It stands for marker size, and it made it 20. All right. So these are all different ways to cosmetically make your charts and graphs look better. All right. So you can use the keyword argument marker edge color, or the shorter acronym MEC, to set the color of the edge of the markers. All right. So right now I've got I'm using the color green, but if I wanted to have the border around the marker, say I wanted to have it be red, so I would do comma, not down there. I'll do a comma here, space MEC for marker edge color, space equals, and what's a good color around green? Maybe yellow. Oh, it's got to be a single quote. Y for yellow. And let's run module, see how this works out. Here it comes. All right. Can't see that too well. But I do see the yellow on the periphery of the green marker. Maybe if I use something else, it might stand out better. Maybe blue. B for blue. Oops. Wrong spot. All right, B for blue. All right, let's do run module. And it's running. Let's see what happens. All right. All right, so I'm not sure if you can see that on my screen, but maybe if I make it bigger. How about that? It's still not very visible, but yeah, you've got blue wrapped around your markers, so it just makes things more visually pleasing. All right, so you can use the keyword argument marker face color, or the shorter version MFC, to set the color inside the edge of the markers. All right, so if I want to, all right, but that's what we're doing right here, actually, with just the G for green, right? But if you wanted to, you could set it. Let's see what would happen. So if I did MFC, so marker face color equals, oops. So if I move this over, space equals, and I will do, so say I want the face color to be yellow. Let's see what happens. If it'll take yellow or green for the marker color. It might get confused, not work. Ah, nice. So it did. Oh, so it took green for the lines. But now I changed my marker color by using MFC right here. MFC equals Y for yellow, okay? So you really, there's so many different little things you can do to these graphs and charts. Understand arguments, color, and anti-marker. Okay, so, all right, let's move on. Now you can also, you don't have to use for these different colors, like for MFC here, I can also use a hex value. So if I wanted to change the color, let's say I wanted to use the color. So hashtag or CAF 50. All right, let's see what happens. So you can use the hex value of colors. Okay. And that's what it does. So it used that hex value, hashtag 4CAF50, and it changed it to this kind of lime green color. All right, so you don't have to just use single letter symbols for colors. You can also go and use all kinds of crazy colors by grabbing hex values. All right, so now let's show you about the lines. Right, so line style. All right, so if you want to use line style, so I'll do that here. All right, so line style equals, I'll do single quote and I'll do dotted. All right, so this is gonna make my line a dotted line by using the argument line style. All right, there it is. Okay, so I'm gonna remove this other stuff too. All right, so that's line style, and so that was dotted. Line style can be, there's an abbreviation, there's an acronym for it. Instead of the full word line style, you can do LS. And say instead of doing dotted, I wanted to use the value dash. I'll do run module. And let's take a second. And there we go. Now we have a dash. line. All right. And keep in mind, we also have abbreviations for things like instead of writing out in the single quotes dotted or dash. So if I wanted to use dash, we also have the abbreviation dash dash. All right, so I can run my module. And you can find all these values and acronyms for MatPlotLib just by looking them up online. All right, so I used the dash dash instead of the word dash, and I still have the dash line. All right, so okay, so line styles, there are 5 of them. There's actually 4 of them. So you have solid, which is the default. You have dotted, you have dashed, and you have dash dot, which will be a dash and then a dot for your lines. Now, line colors, we can do this. All right, so we have color, right? And I'm not going to have dash dash, but I am going to have, say I want R for red. This will be the color of the line. So run module and crank it out. And now my line is red. All right. So that's line color. And you can also, instead of using for color, instead of using the single letter symbol for a color, you can use the hex value. And also the shortcut, the abbreviation for, not the abbreviation, the acronym for color can just be C. And let's, instead of using the letter, let's do hot pink. Let's see how this turns out. Hot pink. All right. Now, what about the line width? So the way to do the line width is keep it hot pink. All right. So it's line width equals the. And why don't we do? Let's see. This has to be in single quotes. Single quotes 20. Single quotes. All right, we'll do run module. And there we go. So you can affect the line width, and of course the acronym for line width is LW. So if I do LW, I don't need the full line width word. All right, so what if you're dealing with multiple lines? You can plot as many lines as you like by simply adding more plt.plot functions. So, all right, so let's say we have, all right, so we're gonna have, we're gonna have 2 y points. So let's say y1 and numpy np dot array, and let's say an array is going to be 3, 8, 1, 10. And this one will be, we'll call our variable, our second variable y2. And this one's going to be sys 2. And remember, it has to, well, actually it doesn't. Sys 2, 7, and 11. All right, so these will be two separate lines. And so we're going to call out plt.plot, and then we have to, I can get rid of this stuff. Well, actually, I'll do y1. Instead of y points, we're going to use the variable y1. All right, and then I'm going to copy this whole line. Right, and we will put it down here. And we'll do plt.plot, and but this time we're going to call the variable y2. And see, it's not going to be hot pinch, it's going to be, I don't know, cyan. Hopefully that works. And the line is going to be, let's say 10 instead of 20 for the width, for the line width. All right, let's run it, see if it works. And it's running. There we go. Nice. All right, we got our hot pinch 20 width line, and we have our cyan 10 width line. All right. So you can do multiple points. You just have to, like I was saying before, do multiple lines. You just have to have multiple y-axes or x-axes. The other one can be the default. So in this case, the x-axis is defaulting to 1, 2, 3, 4. And you have to call plt.plot using the different y variables to get your other lines. So yeah, that's it. All right. So now that's pretty nice. Okay. Now, how about labels? What if I want to label my graph? All right. So with PyPlot, which remember, so PyPlot is a submodule of the MatPlotLib library. And up here, we imported MatPlotLib.PyPlot, and we call it PLT. So in a program, it's referenced as PLT, and then we're calling the function plot. So, all right, so what if, all right, so now we're going to talk about labels, all right? You can use X label and Y label functions to set a label for the X and Y axis. All right, so what I'm going to do is we're going to create a variable S. All right, so we're going to have values for X and values for Y. And what I'll do is 80, 85, 90, 100, 105, 110, 115, 120. All right. And for Y, all right, so this is going to be 240, 250, 260, 270, 280, 290. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I need 2 more. All right, 295, 300. All right, so we have all our values 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so those are all set. And now we can get rid of the second line. I don't need that. So plt.plot. And all we're going to do is we're going to plot the x and y axis. So we'll do x, comma, space, y inside the parentheses. So those are our parameters inside the for the plot function. All right, so I'm just going to run this real fast. And then I'll show you how to add labels to the x-axis and the y-axis. And there we go. All right. So we have our values, our x values, 80 to 120, and we have our y values, 240 to 300, with our line being drawn. And now what we want to do is we want to do PLT and call the function xLabel. And in parentheses, we're going to pass the value average pulse. All right, and enter, and now we'll do PLT.yLabel. And we're going to do calorie burnage. Calorie burnage. Flow, close parentheses. All right, let's run this guy. So run module. All right, so for the x-axis, we have average pulse, and so you can see average pulse is down here. The y-axis, we have calorie burnage, and they put it along the y-axis. All right, so you can see how there's a whole bunch of ways to make the reports look really, really professional, really good. All right, so now we have our x and y labels, but what if now we want a title, right? A title for our plot. So the way to do that is, let me close that out. All right, so now you do PLT. Actually, oops, burnage. All right. And, okay, so how about up here for x and y labels? PLT, that title, parenthesis, and we'll do single quotes. You can use double quotes too, but you have to open and close with whatever you start with. So we have to have opening and closing single quote or opening and closing double quotes. Sports, watch, data, single quote, close the parenthesis. All right, that's going to add a title to our plot, our module, and the report's looking better and better. So we have sports watch data, we have a Y label, and we have the S label. Now, what else can we do? All right, so what if we want to set font properties for our title and labels? All right, to really make this look good. So we want to have a different font and a different font, one font for the title and one font for the labels. All right, the way to do that for the title is inside the parentheses, you do a comma, space, and FONT equals font 1. All right, and so that's referencing font 1. But first, what we have to do is we have to create font 1. So we have X and Y. All right, so let's do font 1. The variable equals, and then in curly brackets, we're going to do single quote family, single quote, and then we'll do a colon, single quote, and we'll do single quote, comma, oops, did something wrong, single quote, and then we have single quote color, that, oops, all right, color, that, colon, and we're going to do blue in single quotes. Come on. So single quote, we'll do blue, single quote. And then one last thing, I want the attribute size, single quote, colon, and then we're going to do 20. And you're going to end it with a curly bracket. Good. All right, so family, attribute family, and the value serif, the color, attribute color with the value blue, attribute size with the value 20. And they all have to be surrounded in quotes, except for the 20, which is a number. It's not a string. All right, so I'm just going to copy this guy, and I will paste it down here, but this is going to be font number 2, right, which we're going to use for our labels. So the font 1 we're going to use for our title, font 2 for the labels, and font 2 we're going to have family, and color is going to be dark red. So I will hit delete, and we will do dark red. And then the size is not going to be 20, but it's going to be 15, because you want the title to be bigger than the labels. All right, so that's our 2 variables, font 1 and font 2. And down here for the title, I've already added the parameter font dict equals, and I've given it the value of the variable font 1. And now for the labels, I will do inside the parentheses font dict is going to equal font 2. And for the other label, the wide label, font dict equals font 2. All right, so the title should be blue with a size of 20 and a certain font, and the label should have the same font with a color of dark red and the size of only 15, so a little bit smaller. All right, I'll run this from module, click OK. Oh, syntax error. Now, when you get a syntax error, it'll highlight exactly where the error is in red. All right, so, oh, that's what it is. I don't have a comma after the color value, right? So I need a comma there, and I need a comma down here for font 2. And you run module. Okay, looks like it's running. Python shell doesn't show any errors yet. And here it comes. All right. Sports watch data, nice big font in blue, and then the label fonts are a dark red and a little bit smaller. All right, so these are all the ways to use MatPlotLib. I mean, there's more to it. You can get into scatter plots and putting a grid on your plots and bar graphs, histograms, and pie charts. We just ran out of time tonight, but I hope you've gotten a bit out of tonight's class using MatPlotLib to create data visualizations. It's all part of the many libraries under Python that you can use to manage and manipulate big data. So thanks again for joining me. My name is Scott Bartow, and this class has been offered to you by the Clifton Park Half Moon Library. Thanks again.